Alright guys, so we're going to be going over assessment video number 6B. The problem states a 60 kilogram woman is in an elevator accelerating upward at 0.8 meters per second squared. Draw a free body diagram for her and calculate all forces on her. Then draw a free body diagram of the elevator and calculate all forces on it, ultimately determining the tension in the rope. So to start this problem off, we can begin by writing everything that we know. So let's see. We have the mass of the woman is equal to 60 kilograms. We have an acceleration upwards of 0.8 meters per second squared. And we have the mass of the elevator is equal to 200 kilograms. So the problem wants us to draw a free body diagram and calculate the forces of each object. So we can go ahead and start with the woman. And we know that woman has a force of gravity on her, which is Fg. In order to support the woman, there must be a natural force. And so now we can go ahead and calculate the forces. Fg is just simply mass times gravity, which is going to be 60 times 9.8. What we get is 588 newtons. So that is the force of gravity. Now we know that at rest, the natural force is proportional to the force of gravity. So we could just say the natural force is 588. But in this case, since we're accelerating upwards, that doesn't flow. And so this is when Newton's second law comes in, and we have to take into account this acceleration upwards. So what we can do is we can say the summation of forces, we know that it's equal to mass times acceleration due to Newton's second law. And we know our summation of forces is going to be the natural force minus force of gravity. And we can go ahead and just replace that with mg because we know what the force of gravity is. And so if we isolate the natural force, we end up with the natural force is equal to ma plus mg. Now if you factor out mass, add acceleration plus gravity, we find that we have 60 kilograms times 0.8 acceleration upwards, 9.8, which is the gravity, and that equals 636 newtons. And so this holds that as we go up the elevator, we tend to feel a bit heavier, and that's because just the natural force is greater than the force of gravity. Now we can go ahead and proceed to the elevator. Let's go ahead and draw our free body diagram. And we have our tension, and we also have our gravity. So we know that our mass of the elevator is 200 kilograms, but we have to accommodate for the woman inside of it. So we can say our total mass is equal to 260 kilograms. And from there, we can use the same process as we did for the natural force. So we can say the summation of forces is equal to the tension force minus gravity. And we know that's going to equal mass times acceleration. Isolate tension. Factor out mass. Go ahead and plug in our values. And what we end up with is 2,756 newtons. So that's going to be our force of tension. And this holds because, as we can see, if we if we account for gravity, which is just going to be mass times gravity, which is going to be 260 times 9.8, we get that equals to 2,548 newtons. And so since our tension force is greater than gravity, we accelerate upwards. And that holds true because we're in the elevator and we're going up. I hope this helps, and I hope you guys learned something.